Hi everybody, this video series is all about SAT math hacks where we discuss special tricks and strategies to solve SAT math problems. This video here is on SAT math hack number 5 and it says use the graphical properties of quadratics. So there are a lot of problems that come up on the SAT that require you to deal with quadratics, and what this hack says is that one of the easiest ways to do that is to think about the graphical properties of the quadratic expressions involved. So let's take a look. Here's our first question, which says this equation here, x plus 5 whole square plus 25 equal to 0, is given to us, and the question says how many real solutions does this equation have. So one way would of course be to expand this expression, write it as a proper quadratic equation and then find its discriminant and see whether the discriminant is positive or negative or 0 and so on. But what I want you to do instead is think about the graphical properties of this quadratic expression here, x plus 5 whole square plus 25, and you can actually do this mentally, you don't really have to draw it out. But what I want you to think about is what will the graph of this expression look like, x plus 5 whole square plus 25. If you think of this quadratic expression, what will its graph look like? So x square is something like this, x plus 5 whole square will be this graph moved 5 units to the left or advanced 5 units to the left, something like this, and then x square, x plus 5 whole square plus 25 will be this graph translated upward by 25 units. So something like this, and again this is a very crude drawing, but you get the sense. You take the graph of y equal to x square, shift it leftwards by 5 units first and then shift it upward by 25 units, and you will get a graph of x plus 5 whole square plus 25, and it is clear from this that this graph will never intersect the x-axis, and therefore it will not have any real zeros. In other words, this equation will not have any real solutions. So the correct option here is option D. Okay, now let's go to the next question, which says what is the value of a plus b, where you have these 2 points a comma 0 and b comma 0 on this graph here of the quadratic function 3x square minus 6x minus 1. So you have this graph, you have these 2 points a comma 0 and b comma 0, and you have to find the value of a plus b. Now this is actually very straightforward, because you can observe from the graph that these 2 points a comma 0 and b comma 0 are the points where the graph intersects the x-axis, which means that x equal to a and x equal to b are the two zeros of this quadratic polynomial, and therefore a plus b is nothing but the sum of the zeros of the quadratic polynomial 3x square minus 6x minus 1. The sum of the zeros of a quadratic polynomial px square plus qx plus r is the negative of the coefficient of x by the coefficient of x square. So the negative of q by p. So in this case, the value of a plus b will simply be the negative of minus 6, which is 6, divided by 3, and that is 2. So negative of minus 6 divided by 3, and that will be 2. So option D is the correct answer. Now if you don't happen to remember this relationship of the sum of the zeros with the coefficient, you can also observe from the graph that a plus b should actually give you the midpoint of the vertex, midpoint of the two roots should correspond to the x coordinate of the vertex of the parabola, which you can see from here is 1. So the x coordinate of the vertex of the parabola is 1, which means that a plus b, the midpoint of these 2 points, or a plus b by 2 should be 1, which means that a plus b should be 2. So you can also make that observation directly from the graph, but this is equally good as well. So a plus b here is equal to 2. Alright, here's question number 3, which says suppose that f of x is this quadratic expression minus 2x square plus 16x plus 9. If g of x is f of x minus 5, for what value of x does g reach its maximum value? So once again, this may look very complicated. You might first try to find g of x by substituting x minus 5 over here, rewriting g of x, and then trying to find where its maximum value will be. But No, that's not how you do it. Once again, make use of the graphical properties and graphical behaviors of quadratics. In this case, f of x is a quadratic polynomial which will open downward. The parabola will open downward because the coefficient of x square is negative. So, let us actually just draw a parabola that opens downward, and therefore it will have a vertex here where the value of the quadratic polynomial will be maximized. The coordinates of the vertex are, if you remember, you have to remember this, minus b by 2a minus d by 4a. So, these are the coordinates of the vertex. Minus b by 2a is the x coordinate, minus d by 4a is the y coordinate. So, in this case, the x coordinate of the point where the maximum is achieved will be minus b by 2a, which is minus of b is 16. So, minus 16 by 2a, and a is minus 2. So, 2 times minus 2. So, that is minus 16 by minus 4, which is equal to 4. So, the vertex of this quadratic graph is 4 comma, let us call it k, minus d by 4a I have just written as k. But the important thing to note is that the x coordinate of the vertex is 4. Now, all you need to observe is that if gx is equal to f of x minus 5, it means that gx is, the graph of gx is exactly the same as the graph of f of x, but delayed by 5 units or shifted rightward by 5 units. So, if you shift this graph right by 5, you will get something identical to the initial graph, but just right shifted by 5 units, which means that the vertex will also right shift by 5 units. So, this point here will be 9 comma k. So, from 4 comma k you will go to 9 comma k, and that means that the maximum value of this quadratic polynomial happens for x equal to 9, and therefore, option B is our answer. So, that is it, that is all you had to do. Just imagine the quadratic moving rightward and then finding out where the vertex would move to. So, now let us look at question number 4, which says quadratic function f of x has x minus 2 as a factor and x equal to p as a negative 0. Okay, so, x minus 2 is one factor, which means x equal to 2 is 1 0 of the quadratic function, and x equal to p is another 0, which we are also told is negative. If the maximum value of the function is at 0.6 comma q, what is the value of p? So, the maximum value of the function is at 0.6 comma q. So, one thing to immediately infer from this is that we are told that there is a maximum value of the function. Now, if the parabola was opening upward, there would be no maximum value of the function. So, immediately from this statement we infer that the parabola is opening downward, because that means that there is a maximum point that the function attains. So, the parabola opens downward, and we are also told that x equal to 2 and x equal to p are the two zeros. So, let me draw an x axis like this, and let us call this x equal to 2. So, this is one of the zeros, and let us call this point x equal to p, which is another 0, and we also know that p is negative. So, p lies to the left of the y axis, or this point lies to the left of the y axis. So, if the maximum value of the function is achieved at 0.6 comma q, so what that really means is that this point here is 0.6 comma q. What is the value of p? Now, from this graph, the problem becomes really straightforward, because 0.6 will not be nothing but the midpoint of x equal to p and x equal to 2, or these 2 points. P comma 0 is one point and 2 comma 0 is this other point here. So, the midpoint of these 2 points will be p plus 2 by 2 comma 0. So, this point here, which will be p plus 2 by 2 comma 0. So, this means that this point's x coordinate and point 6 should be equal. So, p plus 2 by 2 should be equal to 0.6, or p plus 2 should be equal to 1.2, or p should be equal to 1.2 minus 2, which is minus 0.8. So, we arrive at our answer, which is minus 0.8. A slightly alternative way you could have arrived at the same answer is uh, this x coordinate of the vertex is minus b by 2a, minus b by 2a. So, we know that 0.6 is equal to minus b by 2a, and we also know that the sum of the zeros of a quadratic polynomial is minus b by a. So, the sum of the zeros is minus b by a, and we have a 2 here. So, zero point 0.6 will be nothing but sum of the zeros by 2, and the sum of the zeros is 2 and p. So, 2 plus p divided by 2 should be equal to 0.6. So, you arrive at exactly the same condition as you have here, and that will give you p equal to minus 0.8. So, option B is correct. All right. Over to question 5, it says the vertex of a parabola y equal to ax square plus bx plus c is 3 comma minus 7. All right. So, let me just draw quickly an axis here, and we know that the vertex we are told is 3 comma minus 7. So, it lies in this quadrant here. If this parabola neither intersects nor touches the x axis, so neither intersects nor touches the x axis, which of the following could be the value of a plus b plus c? Now, once again, if you start thinking graphically about every such problem involving quadratics, solving those problems becomes really easy. In this case, if the vertex is in this quadrant, so let us say this is the point 3 comma minus 7, this is either the highest point of a downward facing parabola or the lowest point of an upward facing parabola. But if the parabola were an upward facing parabola, that would intersect the x axis, but we are told that the parabola does not intersect the x axis at all, which means that the only option is that this parabola actually opens downward like this. So, we have made our first major conclusion, the parabola opens downward, and now we are asked what is the value of a plus b plus c, or what could be the value of a plus b plus c. Now, here comes our second trick in this problem. We observe that a plus b plus c is the function's value for x equal to 1. If we substitute x equal to 1 into this expression here, we get a times 1 square plus b times 1 plus c. So, we get y of 1 is a plus b plus c. So, what that means is that if I look at the, so this here is corresponds to x equal to 3. So, if I take x equal to 1 here and I try and think about the y value of for this x value, I can immediately conclude from the graph that the y value of this point will definitely be lower than the y value of this point here. So, this point has a y value of minus 7, a y coordinate of minus 7. So, this point's y value must be smaller than minus 7. So, among the options here, the only option possible is minus 8, because the y value at x equal to 1 or y of 1 must be less than the y value of this vertex here, which is minus 7. So, the only option is minus 8, and therefore, the possible option for a plus b plus c is minus 8 in this case, and that solves question 5 for us. Question number 6, now the function f is defined by f of x is ax square plus bx plus c, where a, b and c are constants and a is between 1 and 4. All right. The graph of y equal to fx in the xy plane passes through the points 11 comma 0 and minus 2 comma 0. So, we know we have been told two things so far about the quadratic polynomial. It has a positive a which is between 1 and 4. So, the graph of the parabola will open upward, and we also know the two zeros now of the quadratic polynomial. One is 11 and one is minus 2. So, let us just quickly draw out a rough figure here. So, this is minus 2, let us say minus 2 comma 0, and this is 11. I am not writing out the full coordinates, just the x values. So, my graph will be something like this. And now it said if a is an integer, what could be the value of a plus b? So, if a is an integer, what could be the value of a plus b? Now, from the graph we immediately conclude that the zeros are 11 and minus 2, and therefore the sum of the zeros of the quadratic polynomial is 11 plus negative 2, which is 9. So, the sum of the zeros is 9, but we also know that the sum of the zeros of this expression ax square plus bx plus c is minus b by a. So, what we conclude from here is 9 is equal to minus b by a, which means that b is equal to minus 9 a. So, I am just cross multiplying a over here and moving the negative sign over, and I get b is equal to minus 9 a. Now, we are also told that a is between 1 and 4 and a is an integer. So, this really narrows down the possible values of a. A is between 1 and 4 and a is an integer. So, there are only two possibilities, either a is equal to 2, in which case b is equal to minus 9 times a or minus 18, and from here we get a plus b is equal to 2 plus negative 18 or negative 16, or the other alternative is a is equal to 3, because that is the other integer between 1 and 4, and therefore b is equal to 9 minus 9 times a minus 9 times 3, which is minus 27, and therefore a plus b is equal to 3 plus negative 27, which is equal to negative 24. So, you get two possible values of a plus b, minus 16 and minus 24, and that completes question number 6. And now over to question number 7, the last question in this video, which says f of x is ax square plus 4x plus c, and in this quadratic function a and c are constants. The graph of y equal to f of x is a parabola that opens upward. So, parabola that opens upward and has a vertex at the point h comma k, where h and k are constants. If k is less than 0 and f of minus 9 is equal to f of 3, which of the following must be true? And then we are given two statements here. Statement number 1 says c is less than 0, statement number 2 says a is greater than or equal to 1. And using the information given to us, we have to decide which of these is or are true. Now, this question seems fairly involved, lots of information, lots of statements here, and at first glance it seems fairly complicated, but once again remember our hack. If we start thinking about such situations graphically, they are very, very easy to deal with, and the same is the case here. We will think about this whole thing graphically. So, let us look at all the information given to us. So, we are of course told that the expression is ax square plus 4x plus c, and then we are also told that the parabola for this opens upward. So, that is fact number 1. We are told that the y coordinate of the vertex, which is k, is less than 0. So, that is fact number 2, k is less than 0, and we are also told that f of 9 is f of 3. So, that is fact number 3. So, let us see what these facts put together tell us. So, the parabola opens upward, but k is less than 0. That means that the y coordinate of the vertex is negative, which means that the vertex lies below the x axis. So, the vertex lies below the x axis, but the parabola opens upward. So, we must have a situation like this, where the parabola cuts the x axis at two distinct points. Now, we are also told that f of minus 9 is equal to f of 3, and this piece of information is actually really important, because this tells us that minus 9 and 3, these values of x are symmetrical about the vertex. Let me explain what that means. So, the vertex here is h comma k, and f of minus 9 is equal to f of 3, and let us assume that both of these are equal to, let us say, some value L. So, if you think about this graphically, what does this mean? This means that if you draw a line at y equal to L, if you draw a line whose y coordinate, whose level or vertical level is L, it will intersect the parabola at 2 points, one where the x coordinate is minus 9 and one where the x coordinate is 3. So, for this point the x coordinate will be minus 9, and for this point here the x coordinate will be 3. And if you now imagine the line passing through the vertex like this and vertically passing through the vertex, it is immediately visually evident that minus 9 and 3 are symmetrical about this value of x. And the reason that happens is because a parabola is symmetrical about the line passing through the vertex like this. So, a parabola is symmetrical about this line, and therefore, -9 and 3 must be symmetrical about the x coordinate of the vertex. So, from here we can immediately conclude what the x coordinate of the vertex is. So, this is -9, this is 3 here. So, the midpoint of that is -9 plus 3, which is -6 divided by 2. So, that is -3. It means that this point here is -3 comma 0, and this point here h comma k is actually -3 comma k. So, we have managed to figure out the value of h. Let us first find what a could potentially be. So, now we know that h is -3, the x coordinate of the vertex is -3, but we also know that the x coordinate of the vertex is -b by 2a. So, the vertex of the parabola of a quadratic parabola is -b by 2a minus d by 4a. So, these are the coordinates of the vertex. So, the vertex of this parabola should be -b by 2a. b is 4, a is a. So, -b by 2a will be -4 by 2a. This should be equal to -3, and from here we are able to find our value for a. So, a will be equal to, so I will cancel out the minus signs, and 4 divided by 2 is 2. So, a will be equal to 2 by 3. Alright, and that means that a greater than equal to 1 is definitely not true, and therefore, the second statement is untrue. Now, let us think about what c could potentially be. So, for that what I will do is I will observe that for x equal to -3, the value of y is k, and that corresponds to this vertex here. If I put the x value into the function as -3, the y value is k, and I know that the y value at -3, which is k, is negative, that we are told that. So, what that means is that f of -3 is negative. So, f of -3 is k, which is negative. So, if I substitute x equal to -3 into this expression, I should get a negative value. So, let us do that. Instead of a, I will use 2 by 3 now. So, I will now calculate f of -3, which will be a times x square, or 2 by 3 times x square, which is -3 square, plus 4 times -3 plus c. So, let us calculate this, and I have run out of writing space, but I will just write it between the lines. So, -3 square is 9, 9 divided by 3 is 3, 3 times 2 is 6. So, this is 6, and then I have a 4 times -3, which is -12, plus c. So, this is equal to 6 minus 12 is -6. So, -6 plus c. So, what I found here is that f of -3, which is -6 plus c, should be negative. So, -6 plus c should be negative, and that immediately tells me that c should be less than 6. If I add 6 on both sides to this inequality, I get c is less than 6. So, c should be less than 6, but what this statement says here is c should be less than 0, and there is really no reason to suspect that from our analysis that c should be less than 0. All we can say is that c should be less than 6, and therefore, this statement is also incorrect, and I mean it definitely need not, it says which of the following must be true. So, c less than 0, there is no reason why it must be true, and therefore, we can rule that out, and therefore, we can say that the correct option here is option D, neither 1 or 2 must be true, and that concludes question number 7. So, that was the hack. Number 5, use graphical properties of quadratics to really solve problems, including very tough ones like the last one you saw. If you just start thinking about quadratics graphically, you will be able to solve these problems really easily. I hope you liked it, and let me know what you think in the comments. Thank you.